Good evening, and welcome to my discussion post for IT infrastructure and global enterprises. First, we'll be going over the content, which will be the talking about parallel versus distributed computing systems, computing infrastructures used by competing organizations, advanced business technologies for scalable infrastructure. So first we'll be discussing parallel and distributed computing, what they are a little bit, and then the next two slides will be over each individual one, as well as an analogy of how what helps me understand them. So first, parallel computing. Parallel computing is mainly one machine that has multiple processors. The processors all share the same amount of memory that comes on the computer or device. It's mainly used for smaller data sets as compared to distributed computing. It's not very scalable as the amount of processors that you can add to the machine is limited to the size, motherboard, and just extensions you can add onto the existing infrastructure. It's good when the type of work you need is needed constant communication between different processors and computations. And then distributed computing is multiple devices, multiple computers spread out across your local network, or it could be a wide area network, cloud infrastructure. And so each device has their own processor, own memory, their own unique system. They just process the data and then share their results with the other devices on the network to put the information all together in the end. So it's a lot better for large data sets, sets that don't require near-time results for processing. The scalability is a lot better than parallel computing because you can add as many computers to the network as it can handle, which gives you that much more computing power. And constant communication is not needed as much as parallel computing. So parallel computing, useful situations, examples are for processing simulations, such as weather patterns. It could look at past data and then process in real time what weather patterns or weather may come up, where it could rain, how heavy would the rain be, how much water will accumulate within a specified time, or wind speeds, tornadoes, etc. It can also be used for simulating like fluid dynamics, such as when water does collect, where it may flow on land, where it may stay still, like flooding. And then parallel computing could also be useful for encryption purposes or decrypting, but typically speed is needed for trying to encrypt or decrypt information, whether that's messages or tokens that computers use to communicate with web servers, servers to servers, just across the internet, so people can't steal sessions. And then what helped me understand parallel computing is thinking of it as a kind of like a grocery store, where each of like the checkout lanes and cashiers are the processors. But in this instance, they would all share like one pot of money. So they would each be processing their subtasks, which would be the customers, and then they would be going to and from the money, needing to communicate with which cashier has what money that can be added to the pot, or how much money they need. And so that just the constant communication and speed is needed to get the customers checked out and out of the store. And then the amount of cash registers or lanes is limited, as the grocery store only has a set amount of space they can use for registers, food, products, and then storage in the back. So distributed computing is where, how I described it earlier, there's multiple computers or devices on the network that each have their own processing power, their own memory, their own configurations, and data can be sent to them individually. They would process the data and then send it either to the other computers or just back to the main unit for compilation. And so I kind of thought about this as a beehive, where the bees are the individual machines, and their tasks would be going out to collect pollen for the consolidated purpose of which would be collecting or making honey. And the scalability would be very easy, as just more bees would mean more workers, more pollen could be collected, more honey could be made, or the hive could grow as well for more storage. So next I'll be talking about computing infrastructure used by computing organizations. I'll be discussing cloud, traditional, and hybrid infrastructure, the differences between each one, where they may be useful, and just a little bit of personal knowledge I have with each type. So start off with cloud infrastructure. It's typically just where companies such as Microsoft through Microsoft Azure, or Amazon through their web services, Google through their cloud services, have traditional backend infrastructure. They have the servers, the HVAC, the maintenance, security system is in place, and they rent out the processing services to companies, kind of a pay-to-play system. You pay for what services you use. This can be really easy scalability, as if you need more services, more storage, more bandwidth, you simply pay more for what you're using. And if it's slow, you can pay less for the less services you'll use. This is good for companies that don't, or could be good for companies that don't have a lot of budget, as they wouldn't have to pay for maintenance costs, wouldn't have to worry about security measures, whether that's physical or network wise, and can be customized to the organization's needs in the moment. Some cons for this are that they don't have much control, at least on the public side, of how their systems are secured. They don't know what Amazon or Microsoft may be doing for physical security. Don't know what type of network security measures they have in place. Just kind of have to trust the company knows what they're doing, and is willing to protect customer data. Fluctuating costs, again, for more the public side. As the private side, private clouds are typically controlled by contracts the company has with the provider to set everything in place and keep it at constant cost. But fluctuating costs, one thing I know about this is that my dad uses Amazon Web Services just for kind of personal projects, and he always has to look at his billing information, as Amazon will change their user agreement and may change just the pricing on specific services without really much broadcasting the changes. He has to keep an eye that sometimes he'll have to pay a few dollars here or there that he wasn't expecting. And then performance issues. It's the connection is based on network connectivity. If there's outages in your area, you may not be able to connect to the Amazon Web Service backbone, So your systems could be down for up until whenever that is fixed. And then as well as like bandwidth for whether that's how much you're paying for Amazon or just your network provider could be having bandwidth issues. Traditional infrastructure, the company goes out and buys the physical devices, the servers, the routers, switches, cables, pays for the HVAC system, the maintenance of it, security controls, physical and network wise. Pros is that the company can choose they can do research, figure out what they want to use, and they would be able to then hire people specializing in that type of software or software and hardware to maintain their systems. The less performance issues is that it's on site or could be somewhere close by for the company to be closer to network wise. And they could, if they do have legacy systems, they could purchase products that integrate better with the legacy systems that the cloud may not integrate with due to security concerns, or just can't be supported due to outdated systems. Cons are cost. It can be very, very costly to maintain all of that as well as pay for new products as some hardware becomes end of life, and then the maintenance for both training new people or even maintenance contracts to have a third party come out and maintain your servers, switches, hardware. It just adds more money to the cost, and then a big part is disaster recovery systems. If the company's uh, infrastructure goes down, if they don't have disaster recovery systems, backups, all of their information could be wiped. And it's the scalability would have to be thought of in the as they purchase stuff, they have to consider how easy it'll be to scale 5, 10, 15 years in the future, so that way they aren't spending even more money later on to redo their whole structure. So hybrid infrastructure is what I'm most knowledgeable on in regards to my job. The DoD uses a hybrid infrastructure based on different levels of classification with the data they deal with. Some the higher levels of classification require that the DoD have complete control over how it's stored, security measures, and such. So that would be stored on traditional infrastructure. But the unclassified and kind of lower levels of classification can be stored on private clouds that we have contracts for that specify how that information will be stored, what types of security requirements we need the company to maintain, and such. So pros, security control for both traditional and cloud environments. The scalability is on the pro side, as it doesn't require as much money to scale the traditional side. The cloud can also be also pay to play depending on how the contract is written. Disaster recovery is easier as information can be stored on the cloud and downloaded at multiple locations easier, again, depending on classification. And it can be more cost efficient than full-on traditional due to less space needed as a whole, as well as maintenance and such. And cons, it can be pretty complex to integrate traditional and cloud. And then maintenance costs, as always, money will always be on the con side. Specialized knowledge is a big one, especially as the integration gets more complex. And then data integration is on the con side, as you have to consider like bandwidth, and there could always be network outages and stuff like that you have to plan for and develop redundant systems for. Next, we'll move on to advanced business technologies that allow for scalable infrastructure. Specifically, I'll be talking about containerization, microservices, automation, as well as artificial intelligence. So containerization, I'll talk about first. Basically, you picture a square container, you put an application in it, along with all of the libraries and services that application will need to process data. And they're mainly built on a Linux kind of backbone, but if needed to run on Windows or Mac, there are applications such as Docker that could create kind of Linux virtual interfaces, virtual machines that could then run the application on the Windows or Mac. But containers, they all share, no matter how many containers are on the device, the host OS kernels, as all which can be a good thing, as the containers use less resources than virtual machines may require. They are able to be deployed faster, which is good for like production environments. But sharing the OS kernel can also be a security concern, as one change may affect all the containers, which may bring up security vulnerabilities on some or all containers just based on what they're running. Containers, they store data while the container is running, but that unless there's a method for the containers to send data to a more permanent storage location, all the data the container process can be lost when the container stops, crashes, or otherwise just stops working. And with all things, the more containers, the more complex it gets, the more specialized knowledge, which could in the end mean more money. But it's great for test and dev environments, as well as just production servers, because they're easy to just send it back out. If it does crash, you can just resend a container with the same application to take its place. Microservices. A lot of websites use these day to day. So each service is for like a specific job, such as logging into a website. You would type in the username and password, hit submit, and the microservice would send your username and password through an API call to a server for authentication. And then once you are or aren't authenticated, a separate microservice would then send an API call back to your device, saying whether you are allowed in or not. These are lightweight and flexible, and because they each do a specific individual job, updating one microservice does not affect any others. They are also able to be written in different programming languages, which can be a good thing depending on knowledge base, but also could create complexity as the infrastructure increases. And then infrastructure may need to be updated for microservices, because as each individual job, there's more API calls, there's more logs created, increased network traffic, etc. So that's just something to consider when considering microservices implementation. And with different programming languages, more network traffic, there's increased network security measures needed just to protect data at flow and at rest. These are good for websites, as I said, but also applications that need lots of updates. You can more so for as like you're updating a part of an application, rather than changing one microservice and having the whole application update. however many gigs it is, it would just send an update that's worth a few megs maybe to update that specific service. Automation, uh, automating a task, a machine. This could be done by like a physical machine or maybe a computer, but automating it just means it does exactly as it told. It doesn't learn from the gathered data as it works. You tell it to stamp a sheet of paper, it stamps a sheet of paper, and it'll do it till you tell it to stop. Pros for kind of automation are that they do exactly as they're told, which is great for if something needs precision or there's safety requirements. They're able to run 24/7. Really great for repetitive tasks. Um, some things to consider: the maintenance and update costs, especially as as the system grows, and then the given commands that they follow may not be the most efficient, but that needs a human or maybe even AI to consider what could be a more efficient method. And some uses are machines on an assembly line, automatic payments, such like how I get paid every 2 weeks. The DoD just automates payments sent out to the different banks. And then data ingestion, someone fills out a form, and then the website automatically sends out the data to another service that would then import into the database. And there's artificial intelligence, as I mentioned slightly on the last slide. Artificial intelligence is able to process large amounts of data to make decisions or predictions. It's easily scalable as it just needs more data to make more decisions. It can require more specialized knowledge to implement, but there are also companies that offer pay to use AI services to implement into your website if you aren't looking to create your own little AI bot. And some uses are that banks can use it for fraud detection. I've seen this a lot on websites lately where customer support is now kind of AI chatbots that read what you write and then offer resources rather than just set responses, such as if it was a kind of automated chatbot. And firewalls and other devices can use AI to look for network intrusion. I put that as I had a kind of network defense type job in the past, and I learned a lot about AI in that field. So, summary of what we talked about: parallel and distributed computing systems, the computing infrastructures that are used by computing organizations such as cloud, traditional, and hybrid, as well as the advanced business technologies for scalable infrastructure, specifically containerization, microservices, automation, artificial intelligence. So the next slides are just the resources that I use when putting this presentation together. Thank you.